Welcome to Engineers Mindset. In today's class, we are going to talk about limits and functions of several variables. Now, what is limit? Limit actually explains the behavior of function around a point. For instance, let's say I have limit as x tends to 2 of the function f of x to be equal to, let's say, 3x squared. This is simply saying what is the behavior of this function f of x when x approaches the value of 2. Now, there are numerous of values when x approaches the value of 2. X can approach 2 from 1.5, x can approach 2 from 1.8, it can also approach 2 from 1.9 and so on. But to avoid too much ambiguity, we simply say directly substitute the value of x as 2 into the function, and that will give you the behavior of that function. So if I'm putting the value of x as 2, it simply means here I'm going to have f into this x now becomes 2, and that's simply equal to, so we have 3 into, in place of x now we have 2 all squared because x here is squared. Okay, so this is now equal to this 3 into 2 squared is 4, and this simply gives us what? 12. So it means that the limit as x tends to 2 of this function is simply what? 12. That gives us the behavior of what? The limit at that given point x equal to 2. Now, talking about limits and functions of several variables, we are now going to encounter what? This same situation, but now the point is being approached from what? Different variables. For instance, let's say I have limit as x tends to 1, y tends to 2, z tends to 3 of this same function of this function f of x equals 3xy plus z. So let's say I have this. Now I need to investigate what? The limit of this function are 3 different variables. First is at x equal to 1, next is at y equal to 2, and then at z equal to 3. So this situation is what is called limits and functions of several variables because we are investigating the behavior of the function from what? Different variable perspective. Now, there are 4 methods normally to evaluate limits. The first method is what we call by direct substitution, where we simply what? Put in the point of the limit directly into the what? Function itself, and then obtain the behavior of the function around that point. So the very first method of evaluation of limit is simply by direct substitution. The second method is if by direct substitution the function fails. When we say a function fails, it simply means we have an indeterminate expression. So I will give a brief example to explain what that means. Okay, so after direct substitution, the next thing to try is by factorization method. And if we cannot factorize a given function, then we have to try by conjugate method. And if we cannot conjugate, then we employ the final card, which is the L'Hopital's rule. But in limits and functions of several variables, we can only employ 3 of those methods of limit analysis. The very first method still remains by direct substitution method, and the second method also, which is by factorization method. The third method is simply by conjugate method. Now, the final method of limit analysis, which is by L'Hopital's rule, cannot be applied when employing what? Or when calculating problems on limits and functions of several variables, simply because the function depends on more than one variable, and by L'Hopital's rule you simply have to what? Differentiate. So you can't differentiate one and keep one here. That's why we completely what? Avoid it for limits and functions of several variables. So to evaluate limits and function of several variables, we are going to definitely employ 3 methods. First is by direct substitution. That's a test to directly substitute the value or the point of the limit into the function. Now let's try an example and see. Let's say we have limit as x tends to 2 and y tends to 3 of the given function f of x equals 3xy plus x squared. Let's say we have this function given to us. Okay, now by direct substitution, okay, by direct substitution. So that is the very first thing to do. Whenever a problem is given to you in limits, you have to simply what? Substitute directly first. Test by direct substitution until the limit fails. That's when we can now try the next method, which is by factorization method. Okay. Now, by direct substitution, we have to what? Consider when x is equal to 2. So we do this stepwisely. This simply becomes limit as y tends to 3. So we consider first when x tends towards 2. So you bring it up into this bracket and you keep down the function, which remains 3xy plus x all squared. Okay, so that's how you do it stepwisely. You put in what the limit as s tends to 2. So now we are going to investigate this equation. Wherever we see x, all we need to simply do is what? Put in the value of x as what? 2. All right, so therefore this limit becomes limit as y tends to 3 of the function. Okay, so if I put in x as 2 now, I will simply have 3 into, I have x here, so I'll simply put 2, okay, times y plus, I also have x squared here, so that simply gives me 2. In place of the squared, I simply have 2 all squared. So I have this. Okay, so this gives me limit as y tends to 3. Okay, the function becomes, of course, 3 times 2 simply gives me 6. So I have 6y, okay, plus, of course, 2 squared simply gives me 4. So I have this. Now, the final test of substitution is by simply what? Putting in the value of y as 3. So wherever I see y in the equation, simply substitute the value as 3. And if you do that, we are simply going to have, this becomes, we have 6y here. So this becomes 6. In place of the y, we'll simply put in 3, okay, plus 4. And this will give us simply 6 times 3 is 18 plus 4, which is simply equal to what? 22. Therefore, the limit as x tends to 2, y tends to 3 of that given function, f of x is actually equal to 22. So this limit actually exists. So like I said, whenever a problem is given to you on limit and function of several variables, we have to first of all try by what? Direct substitution. If we put in the value and it fails, if it fails, a limit is said to fail when you have 0 over 0. That 0 divides by 0. That expression is called an indeterminate expression. So if you encounter such an expression, we say the limit has failed. Then we can now try the next method. Now let me explain to you what it means for a limit to fail with an example. Now let's say we have the limit as x tends to 1, y tends to 1 of simply x squared minus y squared all over x minus 1. Okay, so let's say we have something like this. Now, if I directly put in the value of the limit, first of all, as at x tends to 1, I will simply have limit as y tends to 1. Okay, so I'm taking in x now. It becomes x tends to 1 of the function x squared minus y squared all over x minus y. Okay, so if I put in the value of x as 1, this simply gives me limit as y tends to 1, okay, into, now I'm putting in x as 1 squared simply remains, okay, let me see, this is 1 squared minus y all over, minus y squared all over 1 minus y. Okay, so I have this. This gives me limit as y tends to 1, okay, into, of course, 1 squared remains 1 minus y squared all over 1 minus y. Okay, so now I need to put in the limit as y tends to what? 1. So wherever I see y, simply put in the value as 1. If I do this, I'll simply have, this becomes 1 minus, in place of y squared, I simply have 1 all squared all over 1 minus 1. And this is simply equal to 1 minus 1 y squared here, which is 1 squared now, is simply equal to what? Still 1 all over 1 minus 1. So I have this. So notice now that 1 minus 1 simply gives us what? 0 divides by 0, because 1 minus 1 here is 0, 1 minus 1 here is also 0. So we simply have 0 divides by 0. Such a limit is what we call indeterminate. Such an expression is called an indeterminate expression. So we call this simply an indeterminate expression. Whenever you have 0 divides by 0, it is called indeterminate. So for such a case, it means that by direct substitution, the limit actually what? Failed. So it means the limit actually failed when we directly put in the value of x as 1 and the value of y as 1. So since the limit failed by direct substitution, the next thing to do now is to try and see if there is any way we can factorize what? The given equation. So like I said, the very first thing always is to what? Try by direct substitution. If it fails, then you can now try to see if you can factorize the function. Now let's try that and see. We had the function f of xy to be equal to, we had the function f of xy to be equal to we have x squared minus y squared all over x minus y. So we see that we can actually factorize x squared minus y squared. And if we factorize this numerator, we are simply going to have what? Now, this is a shortcut to factorizing this. So pick out one of the x. I simply have x. Okay. Now, bring the sign, which is minus. Pick out one of the y. I simply have y. Close the bracket. Open another bracket. Remember we had what? X squared here. We picked one out, which is this. So which means we are left with what? 1x here. So I simply put down the x. Okay. Remember that here I brought out the sign still as minus. Now I'm going to change the sign as plus. I'll have plus here. Okay. Now also remember that I pulled out one of the y here, which is here. So I'm left with just what? One y left here. So I simply have y. Okay. Close your bracket. All over x minus y. So this now has been factorized. I've been able to what? Factorize the numerator. So which means this x minus y can actually cancel this x minus y. So the limit now becomes limit as x tends to 1, y tends to 1 of the function. The function now changes to what? X plus y. So this becomes easier. With this, I'm no longer going to encounter what is called the indeterminate expression. All right, so what I'll do now is simply what? Consider when x is 1, this becomes limit as y tends towards 1, okay? Now I'm sending x in, so it becomes x tending to 1 of the function x plus y, okay? So I have this. All right, so I'll simply have limit as y tends to 1. Okay, so wherever I see x now, I will simply put in the value as what? Simply 1. All right, so I have x plus y here. So in place of this x, I simply have 1 plus y. So this is it. All right, so this becomes limit as y tends to 1 of simply what? 1 plus y. Now I can now put in the value of y as y approaches 1. So I'll simply put in y as what? 1. So this is now equal to 1 plus, in place of y now, I have 1. And this simply gives us what? 2. So that means the limit of that function as x tends to 1, y tends to 1 of the function fxy is simply actually what? 2 and not 0 over 0. So whenever you have a 0 over 0 function, it means the limit is indeterminate. That is simply by trying first using direct substitution method. And if it fails, shows you indeterminate, the next method to try is what? Simply what? Factorize the given function. If the function cannot be factorized, then you try the third method, which is what? Trying to see if there is a conjugate that you can apply. Okay. All right, guys. So I hope you enjoy this video on limits. I will see you in the next video with more problems on limits by direct substitution, by factorization, and of course by conjugates. Thank you very much and cheers.